We start with a point. Hi everybody, Rob Bryanton here. Thank you for joining me once again at the Imagining the 10th Dimension video blog. Today's entry is about Pole 75 in the series of poll questions we've been posting at the 10th Dimension blog at 10thdimension.com/blog. This entry is called Waves, Curves, and Frames. And Pole 75 went like this. Before our universe and after our universe are both the same thing, the indeterminate state of enfolded symmetry. Likewise, this is what we get to when we try to view smaller than or between the frames of our Planck unit-sized slices of spacetime. That poll ended on December 12, 2010. 79.1% agreed, while 29.9% did not. Not long ago, I posted a new video for an entry called Is Spacetime Flat or Curved? And really, this poll question is about the same idea. I support the scientific viewpoint which says that our universe is not really infinite. Rather, it's finite but unbounded. Let me try to sum up my position again here. 3D is space without time. We can't move within space without using the fourth dimension. So whenever we talk about moving through space, we're really talking about moving through space-time. Some physicists say our space-time is absolutely flat. And some of those physicists use that as a way of saying that if you could travel far enough, you would get to the Earth that is just like ours and see another you who did something different when they got up this morning. I say that's counterintuitive, but I also understand why it receives some support because it places the you who did something different this morning in another universe that is equally deterministic to our own, where you believe you chose one action or another this morning with your free will, but in fact, you're in the one single universe where you were predestined to make the choice you made. And we each live in a grim universe where we really have no control over what we're going to do or what's going to happen to us. Coincidentally, the cover story of the New Scientist magazine that arrived in my mailbox when I was writing this entry was about free will. And here's a video they published about the discussion of whether free will is an illusion. Some scientists who support the idea of there being a slight curvature to our spacetime use this analogy. If our observable universe were the size of a quarter, the entire finite but unbounded universe of our spacetime would be the size of planet Earth. This is a good way to visualize the scale, but when we do so, we have to remember that we're talking about 4D spacetime rather than a 3D physical object like a planetary sphere. Here's where that slight curvature of our spacetime takes me in my thinking. To me, it makes more sense to say that if we traveled through our 4D finite but unbounded spacetime universe with its slight curvature, we'd eventually end up traveling through the absolute zero, the enfolded symmetry that's outside our system. And after an additional 13.7 billion year journey, end up right where we are now. Right here and right now. But if we had adjusted our trajectory ever so slightly in the fifth dimension, we'd have reached the parallel universe where we got up and did something different today. So I would say that other universe is directly adjacent to ours, and the choices that we make with our free will are us navigating through our fifth dimensional probability space with a combination of our choices, the actions of others, and random outcomes. By the way, I posted a link to the New Scientist video I'm telling you about today on my Facebook page, and it generated lots of spirited discussion. I'm going to give you a link here to the many dozens of comments that were posted there. I'm very pleased that 79% of the visitors to this blog were willing to support this idea, that the quantum wave function of our universe includes a null point where everything cancels out, and not only is that both before and after the life of our universe, it's the explanation for why it's impossible for there to be anything smaller than a Planck length. Because that ultra-small measurement takes us to exactly the same place that the ultra-large measurement of our entire universe from its beginning to its end as a single data set takes us to, the point of indeterminate size. That's all for this time around. Next time we'll be looking at Pole 76. I'm calling it No Space, No Time, No Mass. My name's Rob Bryanton. Enjoy the journey.